I'll start sharing my screen. Just to make sure it looks good. Share. I share it this way. Can you see where Zoom? Nope, not this. You're seeing my slides, aren't you? My notes. You're seeing the good slides? Okay, awesome. Perfect. All right, so we'll wait a couple more minutes to do the intro. I see people trickling in. Perfect. It's great to see everyone. Participants. Hello from San Antonio, Texas. Hey, Dan. Good to see everyone. It's good to see familiar names and not familiar too. Hey, Qua. Excited to have you here. Hi, Lisa. All right. I think I'm going to get started. We're going to give a quick intro to Stasio before we start. Let me turn my phone off. There we go. So that we can maximize the amount of time we have with Shanta and Junko, who are really the stars of today. I will introduce myself. I am Ali Menchaca. I'm one of the founders of Project Stasio. And very, very, very excited. This is probably going to be our most attended webinar ever. So we're very excited about that and glad to have everyone here. So I'll get started. For those of you who don't know Project Stasio, I wanted to give a brief intro to it before we jump onto the main presentation. And so Project Stasio is a project that is supported by ibpsa-usa, and it started 2017, 2016. You do the math, but we're almost at 10 years ago when there's this like a joke. There was an architect, a software developer, a researcher, a consultant get together and start ranting about how can we do more to change the way building performance is impacting design. Our building performance simulation practices are impacting design. And we were finding ourselves very frustrated because we felt we weren't really making an impact. Our biggest frustration had to do with, if I go to the next slide, the fact that we were, and sadly still are, but we're trying to change that, talking, not necessarily asking questions when it comes to building performance, but really just giving orders, right? Let's run an energy model, right? We weren't really talking about why are we running it and how are we thinking about this, right? Let's run an energy analysis. And without making the story too long, we got together and tried to think about ways to change that and ways to improve how building performance simulation simulators communicate with architects and owners to impact design. One of the first steps we came up with was we realized that we weren't really even asking questions at all when we were running building performance simulations, that we were just doing the simulation and then trying to figure out why we ran it. And so we came up with a framework on how to frame questions to provide useful answers. Very simple, where we ask what is the impact of a particular variable on a particular metric. This forces us, if we agree to use this format with architects and owners, it really helps us sit down and talk about, well, what metric are we going to use and what variable are we going to use, so that whenever we run the simulation, there's no confusion as to, well, I thought we were talking about daylighting, and someone saying, well, I thought we were talking about energy. So that was step one for Stasio. These are some of the graphics that are in Stasio, which I'll talk a little bit more later. But, you know, for example, instead of just running a massing analysis and saying we ran this massing analysis, saying, you know, we're going to run a massing analysis that evaluates what the impact of massing is on energy performance, or what the impact of HVAC selection on EUI. And so it's a bit more specific, and it can really help us understand why we're running a particular simulation. Project Stasio then took it a step forward and created this online community that is a space for everyone to share their ways to best communicate the results graphically to these questions. Project Stasio is a website that I hope you have all visited, but if you haven't, projectstasio.com is a fabulous repository where anyone can submit ideas or successful graphics that they have used to impact design decisions. So they're framed with the question that I just introduced and have very, very unique ways to answer these particular questions. I, as a consultant, I use Stasio all the time for inspiration when I'm trying to figure out what is the best way, the prettiest way, the most insightful way to communicate multi-dimensional data sets. And I really hope you can use it too. This is our team. So far, the team has grown and expanded and then gotten small and grown again. We're always looking for new members. We are specifically looking for webmasters. If there's anyone out there who's fabulous at WordPress and wants to join the team, please send us an email. Without further ado, and last thing, we are extremely excited to announce our upcoming webinars. So right now, take a pen and write down March 20th at the same time as today. We'll be having the fabulous Shell Anderson, who's a principal at LMN. He is also a Stasio founder who will be talking about what's your lead, storytelling and building performance. He's really passionate about this. If you don't know Shell, you should not miss this. If you know Shell, you know you should not miss this. Without further ado, I will introduce our two speakers today. We're very excited to have Shanta Tucker, who's a director at A10 and co-manages the New York office and is the energy analysis practice director. Her deep experience in engineering and HVAC design expanded A10's Atelier Ten's energy. I just call you by the short name, but I'm just going to go for Atelier Ten's energy analysis practice to include building simulation analysis techniques to optimize high-performance building envelopes, mechanical and renewable energy systems. And then we have the fabulous Junko Nakagawa, who's also director at Atelier Ten's New York office. As an experienced architect, Junko possesses a strong interest in the collaborative work with architects and design clients on high-performance building projects and master plans. She's an experienced sustainable design consultant and expert in lead knowledge and administration. Today, they'll be talking to us about the value, the business case for environmental design graphics. If any of you have ever worked with Atelier 10, you know what I'm talking about. Graphics are impressive, they're nice, they're gorgeous, they lead conversation, and they as a company are well known for that. And so we thought that there was no better guest to talk to us about why not only does it make sense from a design standpoint, but from a business standpoint to focus on graphics. And with that, I'm going to stop sharing and pass it on to Shanta and Junko. If you have any questions, feel free to put them on the chat. I'll be moderating at the end, and take it on.
Thank you so much for having us, and thanks everybody for joining today. I'm Shanta, and this is Junko. We are, first of all, incredibly grateful to Project Stasio for organizing this session, and a huge thanks to this committee for all of their volunteering. I'm sorry, I'm just making sure this is working. So Junko and I work together at Atelier 10 amongst a team of environmental consultants and carbon strategists. And today we are going to discuss what we call the business case for engaging environmental graphics. We think graphics are effective for communicating concepts, a range of ideas, results, and they're great at getting the attention of architects. The goal of creating compelling graphics is really for us to increase the effectiveness of how we work together. And there are so many types of graphics. So today we aim to actually just kind of like open up the curtain behind these and how these were created, why we made the graphic, and most of all, we want to inspire everybody just to make more of your own.
Great. So I think we wanted to start with like, what are the principles that we think about as we are putting together graphics? So this is Atelier 10's drawing principles, just to start. we really think about how can we communicate environmental concept in the most clearest way. And by this, I mean like really focused and simple and straightforward way. We also use graphics often to explain complex information, but it really needs to be easily accessible. And no matter how complex it is, it really needs to be technically accurate. And that's sometimes very hard to do in the graphic sense. And then I think the most important thing of all these bullet points is really just really visually appealing. As Shanta said, we rather want to make really great graphics. So it's really interesting and people want to look at it and people want to understand it. So that's really the most important thing. And lastly, we have some branding guidelines just to make sure our graphics are consistent across the board. So how, as a first step, where do you start? So I think what you want to understand is like, what is the concept that you're trying to communicate and who is the audience? Because that could really change how your graphic could develop. And we want to share with you generally 3 types of graphics that we typically do. And you can use them in different ways. And so that's something that you, as a first step, you want to kind of start to think about as you're kind of planning out this graphic effort. One of the graphics that we do a lot, number 1, is a kind of a summary drawing. So energy as well as sustainability. There's a lot of strategies that goes into a project, and you want to show everything in one so you can see it all together cohesively. And so we do a lot of graphics that are kind of like a summary drawing. And then there's number 2 is like a graphic that we use as a tool to solve design questions or really coordinate with the design team. You have questions, you have options that you want to run through. These are complex diagrams, but it's really more like a tool than like a graphic. But we think that's a really important way to use graphic to what we do. And then lastly, there are diagrams and graphics that are really trying to explain really complex information. So how do we make that easily accessible? And we have a bunch of examples on that Shanta and I are going to go through, and a lot of them are energy related. So hopefully this will be really helpful for you all. So just to start, the first set of slides, I have about 3 examples for the first 2 groups of graphics, and this is one of the summary graphics. You can see there's a lot of stuff on this graphic. This was a competition. We were trying to coordinate with everybody, and we're just throwing a lot of ideas to see what makes sense for this project. So you can see there's a lot of things in here. So it's not the simplest graphic, but it's effective because you kind of see everything in one go. And this particular graphic, you can see the focus was in this atrium in the center, which is like a tempered space that's naturally ventilated. So you can see a lot of colors there to really emphasize that. But we wanted to kind of show a whole range of strategies. So it's in a sketch form because it's early phase graphic that's really meant to kind of excite people and kind of give a bigger picture. So this is one example. And then this is the example of a much later phase project. This is the project in Miami. It's an aquarium. And this is a graphic that the owner, so the previous graphic, by the way, was for the design team. This is more for the owner who wants to just really understand what's the finished product, what are just the key sustainability strategies that's incorporated to this project in a most simple way in a graphic. So you can see this is a lot more trimmed. It doesn't have too much detail, but very refined, very simple, and very easy to understand. So this is really for an owner, like a public use. So
and you used Rhino to help create this one?
Yes, exactly. It's a 3D model Rhino that we extracted the line weights from it and made a diagram that way. Yeah. This is Harlem Mere here in New York. It's an ice rink and also a pool in the summertime. And so this audience is actually the owner and also the public because they're trying to fundraise for this project. So this one is a little more complex in that there's 3 concepts. There's a water conservation and reuse strategy. There's passive strategy because this building is buried underground. There's a lot of passive strategies there with canopy and really trying to keep it very naturally ventilated, very low energy. And then there's also the active strategy of meeting a very stringent local law, energy, EUI target, and really very strategic energy use in certain times. So these three concepts were really important to explain for the public. So we put it all together in this way. So you're kind of like seeing this layer of ideas. This takes a little more coordination. We have to work kind of backwards from this diagram and then filter it down to the three layers. But this is another way to kind of like explain the project in this kind of like simple sequence of things, but trying to keep it together. So it's three concepts, each has a number of strategies, and each layer kind of like reveals itself. So this is another way to show a very like comprehensive concepts in this project. So just moving on to second type of diagram, which is more like a tool. This particular project is a national graphics building. It's an existing building in DC that we're trying to incorporate sustainable strategies to really improve the health of an indoor environment occupants. So here, this was a coordination with the collaborator, all of our design team members, and really trying to figure out two things. And we did it in a very simple way, blue and yellow colors. So yellow is daylight and trying to bring daylight deeper into the space. It's an existing building, so you have to really perhaps incorporate kind of a atrium inside the building. You have to puncture through the existing envelope so you can see the yellow highlighted pieces there. And then the blue is really to update the fenestration because the old existing building needed an upgrade and we wanted to bring in as much daylight as possible from the facade. So very simple, but we're using color also to look at those two components together. This is a project in New York City. It's looking at daylight quality in the space and how to design the facade. So this is really showing incident solar radiation on the east facade, and you can see gradation. And what that shows is that rather than having one tone of color or one level of color on the east facade, because of all the surrounding buildings that are coming up, this is in downtown Brooklyn, we have a gradation on the facade. So it's very easy to understand graphically when you use this kind of gradation of color and how the facade is kind of like, it's different from one side to the other. And what's very neat is that from this diagram, we ended up creating the second graphic, which if you look at the graphic at the bottom left, it kind of looks like the graphic on the previous page, but it's slightly different because each rectangular color is representing an annual average illuminance level on a horizontal surface in a perimeter workspace. So you can imagine someone sitting right by the window. That's how much daylight you would have on that facade if you have no exterior shades. So what that led us to is the graphic to the right, which is gray tone graphic, and that shows what kind of shading we should incorporate into the project by the level of cutoff angles. So 65, 70%, 70 degrees, 75 degrees, 80 degrees. Those are the gradation of how deep the shade needs to be in order to really make a useful daylight inside the space in this perimeter horizontal surface. So if we incorporate that middle guideline of shading strategies, then you would achieve the graphic on the very right bottom, which has like kind of a green and yellow tone. That means that the daylight level is in its useful range, and the photograph just on the top is the resulting end of construction photograph. You can see it's very subtle, but the shade is actually deeper as you go higher in the building and towards the left side of the building. Another tool is looking at stormwater and water management. As you may all know, water is complex. It also requires collaboration with the civil engineer, the plumbing engineer who's looking only at the interior. You also got landscape architect. So there's all these different parties that are looking at their individual section, but there's a lot of overlaps between these experts. So we kind of bring that whole team together. So in order to explain like what is happening overall, we often do a diagram like this that are very complex, but it's really helpful because now everybody can see what their contribution would be. And we can say like, if we do this, this will impact the civil engineer, but then it will impact this landscape architect, and they can all kind of talk together. So this is showing, I know it's very small, but this is just showing 4 different scenarios: business as usual, higher performance, stormwater management strategy, and then the left is like 0 stormwater use plan. So we're looking at like, low to high, where are we going with this project? So we use graphics to kind of use it as a tool to explain what we're doing and then really initiate that collaboration and conversation with the design team. And this graphic led to this second graphic, which is the same project. Now that complex stormwater and water management idea is now distilled down to this very simple graphic, which really talks about, the rainwater being captured and being reused for irrigation. But now, after all these collaboration and conversation, we decided to really treat the stormwater runoff from the roadways and use a hydrodynamic separator to really clean it. And then we're going to further filter it with the bioswale that's going to clean the water. And if there's any water left, it will be will be drained to the river. But by then the water will be very clean. So we probably couldn't come to this conclusion if we didn't have that conversation with the team, looking at all the different aspects of stormwater. So we thought this looks very simple, but there's a lot of work that went into this before we landed to this graphic. And I'm just going to show one more graphic before I pass it off to Shanta with more really complex information, complex graphics. But this last one is Longwood Garden in Delaware. It's a greenhouse, so you can imagine there's a lot of complexity with the different systems working together. So we're looking at summer, winter. We also have like a spring scenario of really looking at how each of these components work together, because there's so many things, there's so many strategies that are working together to really create this specific temperature that they need to maintain for the plants for the greenhouse. So you can see the earth duct and the fans working during the summertime, and then in winter the building is sealed up, so the earth duct is sealed, and then incorporating various heating elements just to heat the people and some of the plants. So just wanted to show another type of graphic that has very complex information, but trying to explain it in a very simple way. So
Junko, what I like about this one too is it's subtle, but sometimes when using Illustrator to do these kind of gradations between warm to cool, it wants to take the blue and mesh it with the red and make purple in between, which is kind of odd. So we're always kind of manually changing it to be just like a white transparent color instead. And it actually looks much more reasonable and less distracting when we can do that. So that's also one of kind of the tips and tricks that I've seen be very successful over the years. So I'm going to go into some specifics on just generally energy. And I have a series of slides here to talk about a pretty wide range of different ways that we've talked about energy. So this first one is a graph that I used as part of a training program for university project managers who at SUNY, which is a state university of New York, they were being introduced to a new operational carbon reduction process. They were responsible for the client side of project management and interpreting and leading the project design teams to meeting a new regulatory process that involves reducing carbon emissions on the operational side. So just as an overall concept, we use this image here to show that there's a starting point. So you have a baseline carbon emissions. There's no scale on this graph, you'll notice. That's because it's not based on data. We're just trying to share a concept idea. And then each of these steps, as you go down to the right, each one of them are exactly the same size. And so we're not communicating that like one part necessarily needs to be focused on, but rather that everybody that has a part in any of these concept or components, they have a role that they need to take, and that no one is more important than the other. And then the other thing that you see in this this image is that we use color just to bring attention to the fact that each one of these components are distinct, and that just kind of helps, I think, make it more interesting and just focus when you're presenting to a big group of people, that you want them to really like to look at what you're showing on the screen. The next one is kind of the classic wedge diagram that we use to show campus level carbon emissions. And this one is for about half a century's worth of time. So we started off by showing the reference year, which was 2006. And the university had stated that at 2006, they wanted to start as their baseline and then reduce by 80%. So that's what that very first, far left yellow arrow shows. And then we started our work after the university had completed this 30% reduction. So starting in 2016. So we want to acknowledge their past efforts, and then from that show the different options at more of a macro level. And these are done in very distinct colors as well. So the intent was that after we showed this diagram, which was a summary of much work together to basically identify these critical points and different methods for reducing carbon, that then you would go through and you flip through the report or the PowerPoint or the book, and you would use these colors as a map. So you would, follow pink or purple or green or blue, very simple, to understand how those different options could be deployed. And what I also like is that there's in between the lines, there's those same colors, so that you can see that the building related measures, for example, in pink, they lead directly to up to the that purple. So you would expect to find a range of building measures after you flip through the report and how to get to this 2050 goal. Also for campuses, I often find it's helpful to have a reference image to show the site versus source boundaries for energy or carbon, or actually any utility. It could also be water. So in this version, the image uses not only colors that are intuitive, but also icons and line types. So this helps basically very quickly and clearly, you can find where your building boundary is, where the campus boundary is, where things are outside of the campus in terms of utility supply. And then quickly, the blue brings your eye. Okay, that's cooling, that makes sense. Ice storage, okay, it's blue, right? So these are just a very easy way to have something to point to and really engage in a conversation between you as a consultant and, say, the campus engineering department, to talk about your points of reference for an upcoming energy model study and say, okay, my work is really going to affect what's happening in this building boundary. But tell me, how could this then affect what you're doing as a campus? What can we do about that?
And I have to say, this is going to be very helpful also for an architect who doesn't usually think about central plant and the campus boundary piece. So it really communicates to all parties, and sometimes even owner side.
Oh, great.
They have all this information.
That's helpful.
Yeah.
Thank you. So that one is different than this one, which is also a site versus source diagram. And this one is kind of inspired by the Sankey diagram. You see that the thickness of some of the arrows change, and that is, referencing that there's more or less amount of those. But the purpose of this one is really about identifying where one could recover waste heat. And so there's just a few numbers on here to draw attention to that being the topic. You could then take this and make copies of it, take off the waste heat information and say, focus on the photovoltaic energy component as a way to lead the conversation and just kind of keep everybody on track. And this is also really good when you have a big conference room full of people that are like kind of they're half paying attention, and then they can look up and know exactly if it's like they need to pay attention because it's photovoltaics and that's what they're interested in. And then the other thing that I think is helpful is that this kind of diagram could be used for another purpose, which is identifying where your purchased energy meters are inside your energy model. You can show them exactly, okay, I am accounting for the purchase energy at this point at the building boundary. And this is something that comes up often with lead energy models that are for a building that's part of a campus. So if you're doing a district energy system study, then you can identify very clearly where you're metering the energy. And you could even add in the utility rates. You could say if it's a virtual rate, for instance, or just layer on that information and then show if you're doing several scenarios. You could do different iterations of a diagram like this and add those. Alternatively, you could use this and expand on it and use it to show submetering and identify where different submeters would go. You could use that to explain how you submetered an energy model. And then if you could imagine, you could build another diagram even further to the right and do a diagram of your building. So within that building box, you could show your annual end uses. You could show the fans, the lights, the pumps, and identify which utility goes to which one of those. And that's an interesting way to kind of map what your energy model is doing in a way that is not a graph, right? And sometimes it helps communicate why it's important to say, pay attention to the fan energy for a project. You could make a bigger arrow for the fan energy so that you could then maybe assign a value to that after your model is done. Next is kind of like the classic bar chart, which I think a lot of us have seen when we're looking at the result of a whole building annual energy study. So I just had to throw this in. Personally, I like it when you have annual energy end uses that are color coded logically, like red for heat and yellow for lighting. The other thing that I like, just want to mention, is it has two vertical axes. So you have the total energy use on one side, and then you have the EUI on the other. And you can do this same thing for carbon and utility costs. It can also be done to show the results for water use as well. You could add in renewable energy. You can raise the point of where your x-axis is and show information below. And you have to be careful with that just to make sure that the sum is correct for those. And so now, like I said, these are pretty commonly used. So I just wanted to show another example of kind of a side-by-side. So I added this slide in to show how we compare the results of the energy model of like 3 different buildings all together. So on the left side column is the results for a library. The middle is a workshop building, and on the right is a community center. So then along the top 3 are those bar charts. But to compare these, we made sure, for example, that the y-axis was at the same scale. That is commonly an issue that I see when I'm looking across reports from many consultancies, is that we're trying to compare information, but the y-axis keeps on changing. And so our client that you basically risks misinterpreting the information. So it's very, very helpful when the y-axis is exactly the same. And almost critically, if you look down here on that bottom row, that's CO2 emissions. And here's an example of when you don't align the y-axis and they all kind of look the same, but the values are very, very different. It makes you maybe you feel good about saving a high percentage, but really if you care about the total amount, it's not communicating that very well. So those are, things that we play around with, and sometimes we sketch them out by hand in advance before spending all that time like in Excel to clean them up, just to see about what we're trying to communicate and to make sure that we don't need to call out information so that it doesn't get confusing for whomever is reading it. So another way to show energy use here. So this is an example of how we discuss the importance of paying attention to high load areas. So what I mean is that if you look here on the left, this is basically just square footage information about a building and its program. So in this energy model, I have 5 programs types. So simple, right? It's probably like a very simple model. So we have 5 different programs, and overall in the building, this is the relative square footage of each one of these program areas. And then on the right, the results from the study show that for those residential spaces, it actually uses less energy, and the yellow, the kitchen, the dining area, proportionally uses more energy. So we use this to talk about why is it important to spend time in like improving building systems for a relatively small area of a building. And this presentation was used to a very large client group with different backgrounds: architects, engineers, project managers, construction managers, to basically explain, well, why are we spending so much time talking about the kitchen and servery when the residential spaces comprise most of the space? Not that those aren't important, but like if we had to prioritize 2 space types, it'd be those 2. A next step one could take in this is then looking at the EUI, so doing like a heat map of energy use intensity. And then you would have those 3 pieces of information next to each other. And it's kind of like basically the same thing as a pie graph, though. It's not really giving you total amounts. And this would probably not be enough to show energy savings. That you would want to use a different type of graphic for. Kind of shifting gears here. This is an excerpt from a study we did for a net zero dormitory building. And the idea was that we knew we had a rooftop, and that rooftop needed to have a renewable energy system that was going to make enough energy to cover all of the energy use for the year. So the way we started was we designed backwards from a budget. So we started from the roof, and we worked with the architect to try to get the most energy production out of the roof and to optimize the array cells and size and space that we could get out of that roof. Then from there we said, okay, this is all the energy we have to work with. Let's have a shot and look at the energy model and see where is the energy going, and can we squeeze it all into the building, right? And we tested some possible scenarios that I thought are interesting to share. So often we just have like a single set point, but here we said, well, what if they don't like heating it only to 70 degrees in the winter? What if they want to heat it to 74 degrees? Like, what is the relative sensitivity of that? And can they have that kind of flexibility to run the building once they're in there in a way that's a bit looser than just like a strict guideline that we impose because we have this, upper limit on energy production? So that's what these bar graphs are talking about. The big blue one is how much the PV system could supply. And then we thought further into the future. So often annual energy use is just like really just 1 year, right? But PV systems degrade over time, as we know. And so we also thought we needed to look at the design life of the PV equipment as well. And so this could be, you know, much more involved and more sophisticated, but like we just kind of showed as an example, if it degrades over, you know, by this much over so many years, will they still be able to run the building as net zero? Should we create an even bigger buffer on the energy savings in this on the system side and the building side to be able to have an ongoing net zero project? And so, you know, these kind of 3 images were used, and we did iteration after iteration after iteration and scenarios here to see what can we do to really make sure that we're always in the dark blue in terms of energy use. So we had, you know, figure out how to drop the consumption even more. And it was a very valuable tool because there was aspects that the engineers could do on the efficiency side, but then there was a lot in the like the FF&E in the equipment that they were put in the building in the first place that of course affects the annual energy use. And so, you know, in all, there's a lot to choose from. You know, I'm sure as you look at Project Stasio, there's so many different types of energy results and how you show them. Whether it's like a day of data or a year or an hour or 50 years. I just want to say that, like Junko said, you want to make your graphics really clear. And actually often we start by just kind of sketching them by hand. So now I'm going to walk through something that's like really hand sketchy and talk about like how we got to what is seemingly looks like really simple image. So like, how did we end up making this diagram? So, okay, what is a diagram in the first place? This is basically showing how we decided to break up a program of a simple building into 3 parts to understand how to approach the process of setting energy targets. So let's say this building has an office, a classroom, and a laboratory, A, B, and C. We know those just by intuition, they have different energy profiles. So we should look at setting energy use targets for them differently. And so this ABC shoebox program categories came out of the following kind of charrette that we illustrated here. So this is a series of slides. So we said that in the concept phase, we wanted to have a goal setting session about passive and active strategies. We wanted to define the baseline and create some options, and then together, do that all together, and then have the design team make the narrative. Well, what kind of results do we need? What kind of outputs are important? Who is going to be the player here? Who's going to contribute? And here's where we, you know, without putting it in like hard writing, we just decided to do it by hand so that folks could change their mind and say, oh, I want to be involved in this, or I think you have the wrong consultant, et cetera, et cetera. And we could just, you know, erase and change this as we go. You could do this on a whiteboard, and then we say, okay, like in this case, we ran the energy models, but then everybody together is going to review the results. And then we're going to run a life cycle analysis, and then have a, you know, an assessment of those results together as the design team, and then present back to the client, for example. So this is just, you know, one way of kind of doing this loosely. And then we said, okay, what do we need to get to the energy model? Like, what are the critical inputs? Well, in this case, the academic calendar was pretty important. Now just sketching them down as a way to get input in the office before we ask the client, you know, making sure, am I missing anything? Am I covering all my bases? What do we think are going to be the key inputs before the building's designed to do this energy goal setting process? So ventilation rates was a question, like, do we have to get a sense of those, or can we just use our best guess? And then how many different massing orientation envelope models do we want to do? What should those look like? How do we explain this process to the design team? We take a box, we take an L, we take an E shape, a U shape, we flip it around, we change the R value on the insulation, we run all these different options. Okay, well, how do we organize that information? So then we had this idea, we would take that like lab, classroom, office, right, and spread it into 3 different options. We thought maybe we'd have this like color coding index, perhaps. I keep on saying that, but I really find color is very helpful in addition to like symbols, in order just to kind of keep a lot of complicated information organized and avoid errors, and like avoid inputting the results from the wrong model, into the results template that we were thinking about making. So it's one of the things I like to do. Labeling and color coding can be very helpful. In the end, I think we figured out that we were going to be making like way too many options from this. So that was helpful. Like, could we reduce the number of models and still get at the same, same result? This was like really meant to instigate conversations. And then what would we do just for one of the program types? For example, how many different options have we got? How many different combinations? And we just use this before we, as an internal document to see if we were overpromising, or we were going to be just meeting their expectations or exceeding their expectations. And I would just encourage you to just get your pen out and your notebook and just like sketch what you're thinking about, and cross it out and try again, and just keep a notebook by your desk and just like always sketch out what you're thinking about while you're thinking. And while you're making a spreadsheet, for example, make a sketch that accompanies it to organize your information, so that when it comes to trying to explain complicated studies like pricing options and life cycle cost analysis, you can kind of go back to your sketchbook and maybe think about making a graphic for yourself, like make a graphic for your team or for the client. And by having that process be parallel to your analysis on the computer, you can be, you can be, and maybe using the other side of your brain to sketch, and maybe you'll come out with a different, a more innovative result by doing that. And by adding a graphic into it, you might get the input from somebody who wouldn't normally relate to maybe a numerical result. And then you'll have a better outcome for the project. It'll have a, maybe you'll come up with something new and exciting and have better buy-in from your stakeholders. So we want you to try it more for yourself.
And this is just the last slide, summary slide, it's kind of reiterating what we just talked about throughout all these diagrams and graphics, but it's really write down key message, as Shanta said, and really be messy. You don't need to be clean at the very beginning. You're just throwing out all your ideas. We do recommend just understanding who the audience is, because depending on that, the graphic might change quite a bit. But again, like, do a rough sketch. Doesn't have to be pretty. Look at the overall graphic, understand what type of graphic you're doing. And I see some questions about media and, programs that you want to use. It's really up to you what you want to use, whatever is comfortable. A lot of our graphics are Illustrator and Rhino, but it doesn't have to be that, really. So it's really up to you what media is most comfortable for you. And as Shanta said, really collaborate internally and externally, because that's really where the best idea comes from. So we recommend doing that. But yeah, we'll open up for questions and comments.
All right. Well, this should go into masterclass. I feel I could watch this 1,000 times and still drool over it. So thank you so much. This is so great. I think everyone is just very excited to see this. We don't have much time for Q&A, and so I'll go straight into the specific questions, there were the tools questions, which I feel, Junko, you addressed a little bit. Mine question is PowerPoint ever the way you do graphics or not necessarily? I think that tends to be often with consultants. There's the, Illustrator and design people who have that training, and then some don't necessarily. We had a fabulous Stasio presentation on doing magic with Google Slides. Do you ever use PowerPoint?
Yes, we do. But I think it's like it's quick, which is great. I even use my stylus on PowerPoint to like sketch and highlight and color things internally, especially to do like peer reviews and markups. But personally, I think like an end like this one, it's not going to be in PowerPoint. You really need it's just a lot cleaner, and you can get the detail here. I mean, this one's like you're really showing an animation of what's happening inside the building and what the systems are doing for those people in this lab. Like you look immediately and you see that like little arm and everything, or the machine. Like I think that depending on how important the graphic is, you have to make the call.
Yeah. Great. There's also lots of questions on workflow and how long does this take? I feel that tends to be the general, sometimes we feel overwhelmed by like, this is amazing, but how do we do it? Do you have, A10 has dedicated graphic staff. And so can you talk to us a little bit about what that interaction is when you interview people? Do is mastering Illustrator and having good graphic skills a minimum to be part of Atelier 10, or do you just have a dedicated graphics team? Do you have a graphics committee? How does it work in reality and putting these and so it's some of these graphics, are they just like the 10 key project graphics, or do you generate these detailed graphics for every project? How do you make that decision?
That's a lot of great questions. I'll try and answer some of them, and Shanta just joined. We do have a graphic designer in our US office, but just one for US.
Oh,
Globally, we have more in London and in Australia, but I think total probably 5, I believe, right now. So not a lot of people, but we have a lot of architects in our office as well, who are just generally very good graphically. So they do some of them themselves. And then all the, Shanta and I also do a lot of our sketches and work with our graphic designers because we like doing that. And all the project managers also do that as well. So it just really varies depending on the graphic, how many people are involved and how long it takes. Illustrators like this for a graphic designer, if he knows exactly what needs to be done, he can probably finish it in a day, but it doesn't.
Fast.
Yeah, makes very fast. But if the information is not quite there, it takes a lot of time, then it could be a week, right? So it really depends on the level of information that he has, and the speed and the tool that he uses. But he does a lot of the final ones you can see here.
And we often sketch them by hand we'll just like we'll get a section from the architect and we'll use trace paper and we'll write just start sketching by hand quickly, spend like an hour doing that. Or sometimes I'll go to Junko and tell her I'm really struggling with this one. These are the concepts I'm thinking I want to talk about with the client, and then she'll spend 15 minutes just kind of thinking about that, or an hour, and then I'll go back and work on it again before bringing it to our graphic designer so that he really understands the intent.
Yeah, right. Good to collaborate.
Yeah, we do. We collaborate a lot on it. And then we also use whiteboards also in the office as well, not just trace paper, but we use the whiteboards too.
And we showed a lot of really fine ones that take a lot of work and time, but we've done a lot of messy ones too. Like Shanta said, we just sketch over on stylus, over a sketch, right? So if we don't have time, we definitely figure out other ways to illustrate it in a simple way that doesn't take too much time. But we wish we have this kind of graph for every project, but definitely not. It's a really selective group of projects.
Great. There are many questions on the hot topic of the year, AI. Are you using any AI to generate your graphics?
Not at this point.
No.
Yeah.
Not yet.
All righty. That was an easy one. There was a question earlier that I appreciated. There's a couple of questions on just the specifics of your graphics. One of them is I noticed that many of your diagrams use a lot of white space and you don't try to fill the page. Can you explain why you make these choices?
Yeah, I think it's really, we want to use color well, and really use the color where we want to emphasize it. So we don't want to highlight anything else in the space unless we want to explain it. Like on this diagram, there are a lot of green space, the brownfield site reclamation number 1 here. And that is, we want to highlight that, but also graphically it looks nice. So there's a little bit of that as well, but we try to really use color and color strategically to highlight something, not just to have it for aesthetic reasons.
Yeah. You're not just to color it in
Yeah.
at all. It's like it's just like on a building drawing set, like if you put something in the set, it's going to be built. So like if you think about the graphic, like what you put on there is what you want to be paid attention to. And that helps that simplicity, I think.
Yeah.
Yeah.
But on the other hand, that means you don't need to be accurate with everything. So it really simplifies, right, the graphic and cuts down over time too. So we don't have to illustrate everything, but we just need to illustrate the things that we want to talk about. So that's the whole communication part. We want to use it to communicate something specific, but not everything.
Yeah, this is great. So some of the things that we teach in our Stasio workshops, which so far have been in person, but hopefully we can make them online for those who are looking for resources, is trying to think whenever you see a graphic, asking yourself, where are your eyes going? And I was taught this tip by someone who, it's hard to do it with a screen, but I do it mentally. It's someone who told me, the way I do that the best is I have the piece of paper, I flip it so I can't read anything, and I ask myself, where are my eyes going, right? And your eyes should be going to the right places. And I feel that the graphics you've shown, I've been doing the mental test of the graphics you've been showing, and I'm like, yep, my eyes are going to what I feel they were trying to communicate. And I think that probably, I love when you show that, you said yellow and blue, right? And those are the 2 colors, like the eyes really go to yellow and blue and highlight that without, it's unconscious, right? We don't need to think about it, but the eyes are going there. So you're communicating something unconsciously. The follow-up question to that was colors. It feels like there is a very unique A10 color palette. Did that come out of like long conversations, and are there big no-nos on like colors that you should never use, and like red, please don't use red, or don't use this green, and etc.? I'm sure, tell us about it.
Yeah, I mean, I think I mentioned it very briefly in the very beginning because I didn't think it was an interesting thing, but I'm glad you highlighted this because it is a very important thing. We have a color palette, Atelier 10 color palette that we use that goes into our Excels when we make the bar chart that Shanta showed, and all of our illustrators that people are asked to use because we want to make sure that all of our graphics look consistent across the board, and we don't want to use colors that we need to use colors that work together, right? That equally emphasize things, and also want to be clear. Like energy is yellow, site is green, but what kind of green? And they need to kind of work together. So we've been developing this palette since the beginning of Atelier 10, and it has definitely evolved across the decade or two. But it's getting a little more punchy. I think we used to be more muted, but now it's a little more punchy, and I think that's just the style of this generation. But yeah, color palette, developing your color palette is very important. That's what we feel.
And it feels you're also pretty standardized on, there's all caps in certain things, and small cap, and not all caps, like sentence and another's, but then sometimes if your slides are titled, it seems to be so consistent, right? That there's probably an onboarding process for like, this is how you follow the A10 graphic guidelines. Yeah.
Yeah,
Yes, we have a manual.
Yeah,
yes.
we do some training as well in-house.
Yeah.
And then our graphic designer is kind of like the person that's just overseeing things. So if he sees something that's really off the chart, then he tried to bring them in a little bit so it's a little more consistent. But yes, those are all, very good observation, I would say.
Fabulous. I mean, we're getting to time. So I'll ask one last question on talking about there's lots of people who want to learn more about how to do things. Are there any resources that you share with, say, your new staff? So here's the manual, but watch these if you want to learn on Illustrator on how to do good graphics. Do you have any resources that you could share with us on how to get started for those of us who might be engineers and were never taught about colors or font or anything else who might want to get started on it?
It's funny, we don't have anything like that.
Well, not
Not-
not that far, but there's the Ching book.
Oh, yeah.
So I came from an engineering education, and we did have architectural drawing, no color though. So I think that the like having 3 line weights, a correct perspective, like those just kind of bones are most important. And then I really rely on my colleagues who do know about color to help me.
Right.
Yeah, I mean that is definitely. So it is collaborative, but I'm not sure about.
Did you mention a book?
Yes.
We can send you a link to that book.
Yeah.
It's a very classic like architecture
Yeah.
book, but it's very simple, but it's really important because that's something that all architects know.
Yeah.
But it's very easy to understand. It's a simple book that we can share.
There's also the book called Sun, Wind, and Light, and it has a lot of hand drawing examples of environmental systems that are inspirational, and that you can, it helps on the technical component,
Right.
I think, which is helpful. And then, if you could think about applying it to the building, that's a great way to start.
Yeah.
Yeah.
I think instead
Perfect.
of starting with a color, I think you want to start more with the technical correctness and the line weights and the perspective, so that you have the framework to work in.
Yeah, that's fabulous. Someone's mentioning obviously Edward Tufte, who's, there's the series of books by Edward Tufte, and he teaches workshops still, I think. If you ever have a chance to take a Tufte workshop, highly recommended. Tufte, Tufte. Well, I think we're going to close it here. This has been the most exciting presentation. Thank you so much. I think everyone else loved it and learned so much. Join me in clapping if you can figure out where the icon there is, and sending your love. Thank you so much. This was great. We look forward to seeing you in our next Stasio webinar, March 20th, with Shell Anderson. Thank you so much, Shanta and Junko. You've done fabulous work, and this is super inspiring.
Thank you, Ali, and thanks, Project Stasio.
Thanks for having us.
Thank you.
Thank you.
Bye.